We've now looked at what A does, what B does, what C does. The only one we haven't looked at is D. So notice that the D is just adding to the outside of my function, so it should either move it up or down, just like we've looked at with other functions when you add something to the outside. So I want to go through one example, and it's listed here. I'm going to do everything I did before, and then I'm going to do my vertical shift last. So I'm going to go ahead and plot my points as if the vertical shift didn't exist, and then I'm just going to move all my points down in a different color. So going ahead and looking at this, so my amplitude is going to be absolute value A. So absolute value of A is just absolute value of 1 or 1. Sorry, my A kind of looks like a 9. And then I'm going to go ahead and I'm going to find my period. So my period is 2 pi over absolute value of B. So notice that there's a 1 in front of the x, so my B is just 1. So 2 pi over 1 is just 2 pi. My space between points is just my period over 4, so 2 pi over 4 is going to give me pi over 2. That's kind of nice since that's typically the intervals I set up anyway. Then I need to find the interval of my first cycle. Oh, sorry, no, first I have to find my phase shift. Didn't find that yet. So remember, phase shift is negative c over absolute value of b. So I see my c is 2 pi, so I'm going to have negative 2 pi over the absolute value of b, which we decided b was 1, so just negative 2 pi. And so then my interval is going to be 0 plus my phase shift, and then the period plus my phase shift, giving me from negative 2 pi to 0 to complete one cycle. And then finally my vertical shift, I look here, since I'm subtracting 1, my vertical shift will be down 1. So like I said, I'm going to go ahead and I'm going to plot all of this information, and then I'll come back and do my vertical shift. So, first I better label my axes. So now that I have those labeled, and I do apologize because they are pretty hard to read, but I am just doing every pi over 2 as like we normally do, or I normally do. And now I'm going to go ahead and say, since it's sine, I'm going to start with a y value of 0, starting at the origin and then taking to my phase shift into account. I go back 2 pi, so I'm going to start here. So let me grab a different color. And then I'm going to go a distance of pi over 2 and put my next point. Sine curves goes from 0 up to 1. So pi over 2, and I go up to 1. Distance of pi over 2 back to 0. A distance of pi over 2 down to negative 1. A distance of pi over 2 back up to 0. There it would be my first cycle. I'm going to continue. A distance of pi over 2 and up to 1. A distance of pi over 2 and down to pi. A distance of pi over 2. And continuing to go through. And then that's going to be more than 2 intervals. So there's a couple intervals. I could also go back, stick some in. I'm just going to go ahead and take up my whole graph. All right, so now from here, instead of drawing in my curve, I'm going to change colors. And if I wanted to, I could draw my curve in still, if that helped me more. But I'm going to go ahead and change colors. And now I'm going to add in that vertical shift. So I'm going to move every point down 1. And notice that I made my axes on the y-axis. I have kind of 2 pieces for 1, two coordinates, I guess, for 1. So it's going to look like I'm moving down 2, but I'm really moving down 1. So I move that one down 1, I move that one down 1. And the reason I suggest doing it in a different color is because it makes it easier when you go to connect the points, when you can see you're connecting all of them of a certain color. So I'm just dropping all of them down 1. All of them down 1. And now making my curve. There is the graph of my function with my vertical shift. And that's it for vertical shifting. So pretty much the same thing, just then moving it up or down.